Today we're going to be looking at compound interest. Compound interest has a formula A equals P times 1 plus I to the power of T, where A is our amount of dollars after T years, P is our principal in dollars, so how much we're investing, I is our annual interest rate as a decimal, and T is the amount of time in years. So an example, a principal of 3,350 is invested, so we know our P is 3,350. And it's in a savings account that pays 3.65% interest compounded annually. So we know our I is 3.65%, which as a decimal is 0.0365. And then we're given a time of 8 years. Now writing our formula, we have A is equal to P times 1 plus I to the power of T. So we have 3,350 times 1 plus 0.0365 to the power of 8. So simplifying that a bit, we have 3,350 times 1.0365 to the power of 8. So we're going to take this to the power of 8, multiply it by our 3,350, and that's going to give us 4,462.72. Now, that previous one only worked for if it was compounded annually. However, most of the time things are not compounded annually. It'll be different time periods, such as weekly or monthly or daily. So compound interest formula for any compounding period is A is equal to P times 1 plus R over N to the power of NT, where A is our amount in dollars, P is how much we invest, R is our annual interest rate as a decimal, N is the number of compounding periods per year, and T is our time in years. So first example, a principal of 6,250 is invested in a savings account that pays 1.75% interest compounded monthly. What is the amount in the account after 6 years? So we know our principal is 6,250. Our R value is 1.75%, which as a decimal is 0.0175. It's compounded monthly, so we know N is 12, and they tell us it's 6 years. So we have our formula, A is equal to P times 1 plus R over N to the power of NT. So substituting in our values, we have 6,250 times 1 plus 0.0175 over 12 to the power of 12 times 6. So we'll go through and simplify this a bit. Calculate, we have 6,250. I would then do my 0.0175 divided by 12 plus 1 gives me 1.001458 to the power of 12 times 6 is 72. I will then do the exponent to this value and then multiply by 6,250 to get my overall value. Which gives me $6,941.41. Next example, a principal of 2,200 is invested for 2 years and earns an interest of $196. The interest rate is compounded quarterly. Calculate the annual interest rate to 1 decimal place. So We know our principal, which is 2,200. We know our time is 2 years. We know the interest earned is $196. We know it's compounded quarterly, so our N is 4. So currently we are still missing a value to get our R value, and that's our A value. We know from previous notes, A is equal to P plus I. So our amount is going to be 2,200 plus 196. So our amount is 2,396. Now we'll use our formula. A is equal to P times 1 plus R over N to the NT. We'll put in our values and gradually rearrange. So we have our A value of 2,396 is equal to our P value of 2,200 times 1 plus our R, which we're trying to solve for, over 4 to a power of 4 times our time of 2 years. So rearranging, first thing I'll do is divide both sides by 2,200, which gives me 1.089 for the left side of my equation, is equal to 1 plus R over 4 to a power of 8. Now to get rid of this power of 8, we'll take the 8th root of both sides. So that gives us 1.0107 is equal to 1 plus R over 4, subtract 1 from both sides. So we have 0.0107 is equal to R over 4. Multiply both sides by 4. And we get an interest rate that's 0.043. So that's our interest rate as a decimal. Multiply it by 100, and that gives us an interest rate of 4.3%. Next, we've got the rule of 72. The rule of 72 essentially tells us how many years it takes for an investment to double. We just take 72, divide it by our annual interest rate as a percentage, and that tells us how many years it will take to double. So example, calculate the approximate amount of years it will take to double an investment when it earns interest at 5.2% compounded annually. So we just go 72, divide by 5.2, and that'll give us 14 years. Okay, so practice for a section can be found on page 630, numbers 3 to 14 and 17.